So check in. Anyway, this is the Tritan update. Thank you all for joining me here to spend a little time with us on a really cool product. You're checking in. Since this is the Tritan update and since I can't recognize all of our team individually, if you're part of the Tritan development team or Tritan specialist team, would you guys let's just start by just standing up so we can recognize you. I want our guests to see who you are. These guys have done a truly phenomenal job in bringing this product to us. Today in this session, I really want to accomplish three things. First, I want to give you a rare kind of peek behind the curtain into what our team goes through in this product development process. I want to show you really what it takes to create and launch a groundbreaking product like this. Now, I'll warn you, some of this process of creativity is a little bit messy, but I hope you find it interesting. Second, I want to share with you some of what we've learned along the way, both in terms of the design and in terms of how we intend to use the Tritan in the field. And finally, I want to paint a picture for you of what your path forward might look like as we help you and your team when you take delivery of your first Tritan 560s in the coming weeks and months. So you all remember it all started back in 2020 here with some of the original concept sketches as we were just really with an idea at that point. And at that time, think about it, 2020, we had several innovative tools that were all designed to perform very well in certain types of applications. 2020, we had the Talon 2000, for example, with that unique bottom-loading carriage, and it had some unique electronics on it. We had the Trackstar I-Series that was, as mentioned earlier on the big stage, it was just in launch just previous to this. And then there was the Acrobat and the Acrobat Quick Fit, built to work in confined spaces, typically where pipe is set overhead and then the machine is installed onto the pipe after it's set. We had this vision of combining some of the best attributes of each of these with an overarching goal to help improve safety and increase efficiency. And at this point we had a great idea, but something like this had really never been done before. So what did we need? Before we could really do any design work, we needed a proof of concept, right? We have to prove to ourselves that this idea is realistic, that it's achievable, and this thing may actually do what we think it could do. This was September of 2021. It was really rough. It was down and dirty, but it was a start. We followed that with this second attempt in October of 2021. Still rough, using a lot of materials and components that we had on hand, and without a ton of analysis or attention to detail. There were no style points at this point. The idea was, how do we fail fast to succeed sooner? And what might reasonable expectations be for a product like this? What might that actually look like? Then on to further refinement. It's starting to look like something at this point. It's still not pretty. It's quite a mess, but it is progress. Then to this. In September of last year, just over 12 months ago. Wasn't perfect, it wasn't even necessarily complete, but it did work. And this is what we were able to show you and to demonstrate just a few short days after it was complete at INFUSION23. Little did you know just how new this product was. This was the alpha prototype. The very first real prototype. And for a first prototype, I got to say this thing looked great and it performed really, really well. For a new product, for you guys, it had just magically appeared at Infusion. But for our team, literally thousands of hours had already been invested in very hard work. And just to remind you, I want to take you back to the energy and the excitement that the Tritan brought back to the main stage at INFUSION23. Remember, the lights went down, the noise came on, and then the hype video came on. Yeah. It literally sucked the air out of the room. I mean, I could hear audible gasps from the crowd when you realized what you were looking at. But immediately after Infusion, immediately after, it's right back to the old drawing board. The hard work and heavy lifting had really just begun. Based on what we had learned building the alphas, as well as our own observations and your initial feedback from the showing at Infusion, we had to ask ourselves, what will make it even better? And concurrent to the development process, we're also working to try to build on the enthusiasm of the launch. In January, we did a webinar with the Pipeline Industries Guild out of the UK featuring the Tritan 560. And I couldn't see the actual number of individual attendees, but I know there were 25 different Pipeline Industry Guild companies in attendance, and each had multiple attendees. So very well attended. Thank you, Alex, for organizing that for us. This was followed by the beta prototypes. Now, while the beta looked almost identical, there were actually significant improvements over the alpha machine. The beta is what we had to make the awesome showing of at Con Expo back in March of this year in Las Vegas. Now, I don't know how many of you may have made it to Con Expo, but let me tell you, for the Tritan, this was a fantastic trade show and may have ruined us for all future trade shows to come. We had an awesome location, great traffic, and the show had RFID tracking devices in each of our name badges. So they were able to give us some really great feedback on how many people passed by our booth, how many stopped or passed through our booth, and of those that stopped, how long they stayed. There was almost 70,000, I believe, that passed by our booth. Of the 70,000, around 30,000 stopped or came through our booth. 30,000 people. And of those that stopped, they stayed for almost 11 minutes apiece on average. That was a phenomenal reception for the Tritan 560. Of course, we had other products there, but the Tritan was really a draw. And from March until today, there's been a monumental effort inside McElroy to make the move from product development into production. For example, we've done environmental testing of all the components and systems to help us determine if this thing will actually survive in the wild. We test all the various functions in temperatures ranging from 0 degrees Fahrenheit up to 120 degrees. And that's like -18 to around 49 degrees C, I think. You can actually see the ice on the floor that's forming on the Tritan here. And this isn't just a simple pass-fail type of test. This machine is instrumented up like a patient in the ER. They're measuring and tracking temperatures and pressures, flows and voltages on basically everything. And what you can't see in this picture are the teams outside the environmental chamber, observing and taking the readings. They represented mechanical, hydraulic, electrical, and software. And they were all there to see how their pieces of the puzzle all performed in these extreme environments. And we also do more conventional validation and performance testing, also known as, let's test the limits of this machine and see what breaks. Now, this is fun in some demented sort of way, but it's also a little bit scary, okay? And when we do break something, when we find what we're looking for and testing for, we have to determine why that happened. And when I say we, I don't mean me. I mean this great team that we've got here. They determine what went wrong. And then it's not just a matter of fixing it, but rather, what do we need to change to make sure that it doesn't happen again? They then revise the design, build new parts or retrofit components. They make the updates, and then it's right back into validation. Did our update deliver the expected performance? Or did the change that we made inadvertently affect some other seemingly unrelated component or system? In other words, did we just fix one problem only to create another one somewhere else down the line? All the while, our software and innovation team is behind the scenes. They're making refinements to the code. They're adjusting how the machine performs and reacts. And they're improving the brand new user interface. This is where we can really begin to dial in some of those finer features and the details on the interface of how the machine is actuated, how it performs, and how the heater logic works. Now, our I-Series experience really paid off for us in this area. The systems in the Tritan are different than the I-Series, but the software levers that we have to pull to change behavior are very similar. And oh yeah, we performed our in-house field validation, known inside the company as Fusion Fest. This is where we begin to learn how to use the machine in its natural habitat out in the field. We get to figure out how we're going to use it, what are the best practices, and what do we need to be prepared to teach you as new users to make you proficient faster. Now, we did this with small teams who brainstorm ideas to prove out or myths to bust. We asked ourselves, what do we know from our past experience that may help us with the Tritan? We learned perhaps what we know from our past experience that doesn't even apply. And finally, again, what are those best practices that we need to establish, that we need to document, and we need to prepare ourselves to pass along? As a participant in this process, I have to tell you, as Mike mentioned in the data logger presentation, it was hot. We operated on some days in the 103 to 105 degree Fahrenheit range, and nobody handed us a set of instructions on how to do this or what to look for. But again, we leaned on our I-Series experience, and that paid off by giving us somewhat of a roadmap on where to start. But from there on out, it's been all about discovery with this new platform. In this picture, for example, it's hot. We're running cowlings off with the entire machine taking a full sun load. We measured surface temperatures that ran up to 165 degrees and beyond. I'm talking about on the engine reservoir. I'm talking about on the battery charger. Talking about on the generator. And while system temps, surface temps were up 165 and above, system temps stayed down between ambient and about 135 degrees. All very acceptable numbers. So impressive performance even in the heat load. And one more minor detail. How are we actually going to make these things in a production environment? Chip mentioned our new facility. We're already in need of expansion. And remember, this machine isn't replacing something else. So where are we going to build it? What tools and equipment are we going to need to do that? Where do you start a build process on something like this? And what comes first? These are all questions that don't get answered on their own. And in this area, no stone goes left unturned. If our first articles aren't just right, we have to adjust very, very quickly. If we don't react immediately, what happens? We start making scrap. If the design needs to adjust so we can make a part, or so we can get a wrench on it, or so we can gain access to it, what all else needs to change to accommodate that? And if outside suppliers or vendors don't meet our expectations, how do we change course on the fly to still achieve our goals? And through all these experiences, through the successes and failures along the way, we've developed our Tritan specialists. Now, this is the team that will work with you and your Tritan specialists as we move this machine out into the field. They represent sales, technical support, quality, McElroy University, and of course our international team. So what have we learned along the way? Well, we learned that weight is essential for stability. And I'm speaking about counterbalance weight, just added bulk weight, as well as a shift in the center of gravity. In this case, we've added about 15% to the weight of the original Alpha machine. We've increased the weight 15%. But the great story is, for that 15% increase in weight, we've increased the tipping point about 30%. So it takes 30% more load for it to become unstable on the ground under load. We've learned that stronger, stiffer, and heavier is better. What you're looking at here are the heater and facer pivot arms in that picture. That's made out of 2-inch steel plate. We learned that the user interface needs to be laid out for efficient workflow, keeping in mind that we have new functions to control on the data logger. We learned the new heater works really, really well, not only in terms of temperature, but in terms of sound, ergonomics, and fuel consumption. And of course, thoughtful setup helps us improve productivity. With a new approach, we have new needs to consider in our setup. And it's crucial that you establish a good process workflow. Process workflow. What are we talking about there? Process workflow or process logic. Think of how your best operators perform on a legacy machine. Whether it's well documented or not, experienced operators know exactly what their order of operation is. From the time the first length of pipe's loaded in the machine, right through the completion of the weld and transition to the next joint, they know exactly in advance what their next move will be because they've done it a million times. But with the Tritan, it's different. What we learned through our experience is that you really have to become familiar with that wireless interface so you know where you need to go to control what function. We learned that some accessories work better than others. Some are too high, some are too low. Some are not stable enough, or they're not ergonomic. And before you can even approach the pipe, you want to have certain parts of the machine in prescribed orientations to provide you with the maximum amount of adjustability over and around the pipe. We've learned when and how to use auxiliary equipment and what adjustments are best performed using the Tritan and what adjustments are best performed using a piece of support equipment. We learned that when you approach the pipe to make the next weld, we need to know what to do first. People on a legacy machine are presented with a pipe, one pipe in the fixed jaw, they know exactly what to do, another pipe in the movable jaw, they know exactly what to do. With the Tritan, we're going to preset the pipe typically in advance of the machine approaching. So you're presented with two pipes at once. And two pipes at once typically aren't going to be alignment. And we have so much more adjustability in the Tritan that brand new users, if not given a roadmap, will become confused on where do I start? What do I do first? We've had to make that clear. And when a joint is complete, then how do I effectively transition to the next joint? So what can you expect? First, you can expect that there's a whole bunch of your I-Series experience that's going to translate very well to your Tritan experience. The familiarity you have with that platform and interface is going to naturally carry over to the Tritan. So thankfully, we're really at a different starting place with the Tritan than we were with the I-Series, at least from an introduction and launch perspective. But there's so much more functionality on the Tritan that it's just going to take a little time behind the wheel for you to get comfortable with the Tritan itself and to wrap your head around how to best use it. So we plan to make plenty of time for working in the field in simulated real-world applications. In an attempt to jumpstart your orientation and your familiarity with the interface, we've developed a new trainer mode on the Data Logger 7. Now, this is so you can go through simulations on the interface, whether you even own a Tritan or without being connected to a machine at all. Now, this can be done in advance of your initial training from your own office or home, so you won't be starting from ground zero when you get your hands on the machine. And as I said earlier, you will need a good process logic to stay on course. So we'll be sharing our document with you, the one I showed that we have developed, for your review, for your familiarization, and for your hopeful refinement, given your unique environments and functionality or needs of your applications. And once you understand the logic and the control scheme, the pieces will start to come together quite nicely and much more naturally. So let's explore the trainer mode. Now you'll be able to access this from any Data Logger 7 once it's updated with the very next software release. It's not out yet, but it's coming very soon. To access the trainer mode from the Data Logger 7 home screen, you just go to Settings. From the Settings screen, you click on System. Then scroll down to the bottom of the page to System Settings, and there's a trainer mode. There you click on Manage, and from the trainer mode settings, select the Tritan and then Done. You don't have to remember all that, but it's pretty simple. Click Done, and it takes you right back to the Data Logger home screen, but now that big McElroy logo in the top left-hand corner has been replaced with the Tritan logo, indicating that you're into the Tritan simulator. You'll also see what looks like a little cassette tape in the lower right-hand corner. It's not a cassette tape. It's meant to represent a couple of joysticks. But this is a very important function here. Click on this icon at any time from any screen to go to the Tritan machine control screen, which looks like this. And all these controls will appear active in the simulator, but you obviously won't be connected to a machine or controlling any actions. But it will help you build some muscle memory and help you familiarize yourself with where you can find all the various functions. Note it's broken into 3 sections. The center section doesn't really change, but you can activate either tracks, indexing, or jaws. And then on the right side, boom or carriage. The tracks are activated right now. That's on the left. Boom is activated. That's on the right, giving you boom and swing extend. You can operate these functions 2 at a time. Anyone on the left with anyone on the right, but you can't control 2 functions on the left simultaneously or 2 on the right simultaneously. You also have an engine start stop and hydraulic stop, very similar to what you see on the Trackstar I-Series. Lights and information, that little I down here, you can click on that and it's actually going to bring up some additional performance data on the Tritan 560. Some of the information that you might otherwise on an I-Series machine, for example, have to go around to the vehicle display to see. It puts it right up here on the screen. You can switch all those selectable controls, and you can see this data logger icon at the bottom center. This one's important too. Click on this at any time to return to the data logger screen. Now, from a Fusion standpoint, the data logger functionality is identical to the I-Series. It features the same 3 Fusion levels and the Fusion guide scheme. But what isn't I-Series like is that the Tritan doesn't have those same keypads, those touch pads that the I-Series has, and it doesn't have those paddle switches. Okay? All carriage functions that aren't automatic on the Tritan will be performed using that little lower right-hand icon and going to the Tritan control screen. For example, if I'm in level 1, when it comes time to close the carriage to start the beat up, you switch back to the Tritan control screen and you close the carriage just as you would on another machine, an I-Series machine with a physical switch, but you do it in this case on the wireless data logger tablet. Then back to the data logger screen where you'll see the normal data logger graph just as you would expect if you were working through a Fusion on a live machine. This is a live simulated time and pressure graph, and all other simulated readouts, just as you expect, performing an actual Fusion. Now, once the simulated Fusion process is complete, you'll be asked for the same kind of confirmations that you would expect in the actual operation, and you'll even be presented with a simulated joint report for your review. Again, all the look and feel of operating on a live machine, but in a simulated environment. So let's talk about the learning path from McElroy University that they dubbed training when you need it. You can see the various modules. There's pre-launch. Pre-launch, think of this as an orientation targeting those who are thinking about or just purchased a Tritan, or those who are about to receive their initial training. There's quick launch, targeting those who have a machine en route, focusing on what you need to know on day 1 of receiving or owning a machine. There's training in the shop. This is maintenance or troubleshooting training. And then on the job site, of course, this is operations. And note this circular path between quick launch in the shop and on the job site. I mean, what is that all about? Well, we learned from the I-Series that whether you're in sales or you're a Fusion technician or a trainer or a maintenance guy, all of you need to know some aspects of each of these different segments at some level. But you don't all need to know how to change the fluids or even fuse pipe for that matter. But you do need to know things like, how do I start this machine? How do I make a wireless connection to the data logger? How do I navigate between the data logger screen and the Tritan control screen? And then how do I perform any needed software updates? So hopefully now you have a better feel for the progress we've made over the last year, as well as what we've learned along the way. And you should have a better idea of what to expect in the coming weeks and months as you prepare to take ownership of your Tritans. Excuse me. I'd like to leave you with a little challenge. before we go to questions. Now, going back to the I-Series launch, you guys did a great job of highlighting on social media your activities and efforts with webinars, with training, with promotion, with field success. Remember that the I-Series came out during the pandemic, and in many ways we didn't have a choice. But I believe the result of those efforts was that it helped to push that platform into the mainstream much more quickly. As you begin your Tritan experience, I challenge you to make your efforts known on social media in much the same way. And when we're back together here next year at INFUSION23, I'd like to recognize a Tritan champion with a special honor for their efforts for online promotion and with the Tritan 560. So with that, I will open the floor to questions. Charles, we are going to have the opportunity at Product Showcase tomorrow. We'll have 3 Tritan machines out there. One will be operating, running it through its various motions. One is going to be static on a piece of pipe that it has fused. And then we've got a brand new Tritan 560 right off the production line that will be under a tent that you can climb around on, look, open the door, get to know. We'll also have some simulators there. I think 3 or so of the data logger simulators. If you want to get a feel for what that's all about, I encourage you to get your hands on that. So, with that, questions? Mr. Perrault.
You mentioned that you found out in your testing that some accessories worked well with the Tritan, but some didn't.
Some didn't.
Which ones didn't?
So, for example, at Infusion last year, one of the ways we showed the Tritan 560 was on a set of low-profile rollers. Okay, it's doable, but to get down after face-off, for example, and clear those shavings and actually inspect your alignment, you literally have to lay down flat on your belly to work with it. And so, as I've watched our guys operate, I've just seen them migrate away from that type of accessory. It could probably be managed in the right conditions, but it wasn't very ergonomic. Yes, sir.
You guys plan on coming out with something along the lines of the low-profile roller, but in a higher version outside of just regular pipe stands?
Well, we've got the MegaMac rollers, okay, that are higher. Our guys, and you'll see tomorrow in our display at the product showcase, have kind of migrated towards using pipeline cones. We use 24-inch cones. They're quite stable. We don't make them, but there are a lot of them out there, especially in the markets that I think we'll see this thing in. And a 24-inch cone on a 22-inch maximum diameter pipe gives the pipe some freedom of movement while holding it in a relatively stable condition and at a comfortable height. That's one in particular, one that seemed to work real well. Other questions?
And Chris, I think the machines that are being delivered outside the US, obviously it's a very new machine, which you pointed out the operator is quite different.
Yeah, Dave.
Function is different. Will the potential to get that training be available?
Absolutely, absolutely. The expectations for training and support for our international customers is going to be no different than our domestic customers. Okay, we want to get you exposed to the machine before you actually take possession of it, and then we'll be following it out, and we'll making that next step. Yes, sir. Exactly.
It's going to be a very, very different experience.
It is going to be a different experience. I agree with you, and we want that first experience to be absolutely positive.
Because some of the stuff used correctly, then people feel that it's not because it hasn't got the potential that they thought it had, but it's because they're not using it correctly.
That's exactly right. It's been interesting as I've seen people view the Tritan for the first time, even going back to INFUSION22. There was one of two lenses that you could use to view the Tritan. One is a lens of, I see the machine, I know what I do today. How do I do exactly what I do today with that machine? And it's not, the end result of that's generally not positive. The other view is I see a new technology, a new platform here with new capabilities that I've never had before. Having that now, what might I do differently to make my job site safer or to gain productivity or gain efficiency? And through that lens, the Tritan really shines brightly. Same machine, same application, two different points of view.
I mean, we've got guys, everybody has, that are absolute experts at using a standard traditional design machine and maximise productivity.
Yeah.
But
Go back.
They're not going to be able to apply that methodology to the Tritan. They're going to have to start again.
Yeah, you got to start again. And I think back to the presentation we had earlier today, the keynote about change. Okay, think about how much of that applies to exactly what we're discussing here. Yeah.
Not a thing here, is it?
No, that was not intentional. That was not intentional at all. It's an observation I drew because the gentleman that spoke to us happened to sit down next to me to have his lunch.
Yeah.
So I had a fun time having that conversation with him. Yeah.
Do you know what the lift capacity of that is? I mean, obviously 22-inch pipe, you're not just gonna run thin wall pipe everywhere. What is have you guys established a maximum lift capacity?
I don't think it's as much about lift capacity as about tipping point. And the idea of the Tritan is not that it's a material handler necessarily. It is capable of doing some of that work, but in a typical fusion capacity, you're not lifting pipe really. Any of the diameter and SDR range within its capabilities, it can actually handle the end of the pipe real well. If you're interested in getting into the center of the pipe and raising it up and carrying the whole length of the pipe around, you could get into some areas. We've got the guys in the room that know the exact tipping points. I don't want to. It's different in every orientation of the carriage in relation to the tracks, so it's not just a number, but then it's also a bit of a misnomer tipping point where if it's too heavy, if the machine would otherwise tip under that weight, it's not going to pick it up in the first place, so it's not going to tip. It's just not going to lift. Okay, so, but we're nowhere near those weights in any of the fusion applications we've run into. And it is quite stable on the ground.
Hey, Chris.
Yes, sir.
I'd like to talk about, you touched on the weight increase of what they saw a year ago, and I think it would be very instructive to share with them that that was all an outgrowth of what we learned in not handling the pipe, but manipulating the pipe.
Yeah, that's exactly right. This wasn't a matter of how much can we carry around, really, but the feel of the machine as it's doing the job it's intended to do. And we made our own observations, and we got some very good feedback from those initial viewings of the machine. And it really is a matter of arriving at a point of stability that when you look at the machine and you operate the machine, you have every sense that this thing's solid. Okay, being new, being different, being unlike anything else in the market, the doubting eye can tend to say, oh, there's a reason not to use it. There's another reason not to use it. And any of that tippiness was kind of part of that. And it is quite stable now, even under load. Yes.
I might have missed it, that you may have said it already. Have you guys identified what the productivity changes are in this over like an I-Series or over a T5 or something?
We've not done a direct measurement at this point. We probably will at some point. As I think about operating any conventional machine, ours or anyone else's, the legacy machines, depending on what type of operation you're in, you're going to fuse a piece of pipe together and then you're going to transition to the next joint. In that transition time, whether you're tracking or pulling pipe or whatever you're doing, that's a variable. But then you're going to arrive at the end of the pipe one way or another. And let's say that's fixed into the machine. and you're gonna get to clamp on that fixed end so you've had transition time, clamping that pipe, loading the next pipe, which can begin really at that point, once I've transitioned to the end of the first one. The loading of the second pipe can't start until I've transitioned to the end of the first one. And so you've got that transition time to deal with there. And in the case of the Tritan, the pipe can be pre-staged. While one joint's being fused, the next joint can be staged. So you're at least picking that time up. The fusion process is essentially the same.
Yeah, I was just curious if you had identified.
We've not done a study at this point, no.
Chris, what have you looked at, like, this inclement weather? So, like, obviously, it's, like a shelter or there.
Well, we've been using just tents, I don't know, I call them tailgating tents. You're not gonna be fusing in the rain unsheltered, right? With the Tritan, you only need to shelter, you don't need to shelter the entire machine like you might with any other machine. You just need to shelter kind of that fusion work zone. So we've been using those just tailgating tents.
Any issues with distribution so far? Like, taking carriage off for distribution? Any issues with taking the carriage off for any?
Well, the carriage comes off quite easily. You've got the hoses and cables to disconnect from the bulkhead like you do on an I-Series, for example. And then you just pull two detent pins, and the indexer just rotates out from under the carriage. It's quite fast. And then it's a 4-point lift. So it's ideal for in-ditch work. You'll also see tomorrow at the product showcase our in-ditch kit, which is a stand and the extension hoses and those things. That's very robust.
Chris, one reminder on in-ditch, the heater facer.
Heater and facer, yeah, for in-ditch, the indexer functionality does not come with the machine off a vehicle, so you would be lifting the heater and facer in. You'd be picking them, okay, in from the top. Thus the need for the in-ditch kit, the stands. Sergio?
Yes. What about the drug capability on your testing, and also about the total effective piston area, just to have an and how much force?
The piston area, engineers help me out, is somewhere just under 10, I believe. 10 square inches, just under 10 square inches.
10?
Yeah.
Smaller than 4 foot.
But with more system pressure.
More system pressure?
Yeah.
Yeah. And about the drug, the behavior of the jaws, have you tested, I mean, more than pulling more than one?
We've done slip testing on it. We've not run into anything we couldn't overcome in that area. And for slip testing, that's done in a 3-jaw plus 1-jaw configuration. We haven't had any issues with slipping in 2-jaw and 2-jaw at all. It'll take full system pressure.
Maximum DR that is specified?
We've got, well, we have some 5 out there that we've been playing around with. I don't know. I don't know that it's got a limit.
You said you got some DR5, you're talking 22-inch DR5?
It's 20 or 22. I'm not sure which.
That was gonna be my next question, is kind of what DR range are you guys comfortable with?
Let's be very clear, the 22 DR5 we bought because of its extreme weight. It's not a standard pipe material. It is pipe that is extruded for fitting fabricators that wind up putting in a lathe and turning it down.
Absolutely.
So the DR5 has let us prove that it can handle the weight and rigidity. But I think DR7 is the most that's out there at 22.
Yeah, and I think we designed around something just heavier than 7. So we have 5 minutes left here. Additional questions? These are great questions, by the way.
Hey, Chris, I've heard some rumors from a few individuals here that they're questioning
Yeah.
maybe from a few people, so could you attest to?
I'm a witness, yeah. I did hear that question third hand, kind of, and I chuckled. And I was reminded of, I told the story earlier, I'll make it fast, but I was reminded when we came out with the line tamer. We came out with the line tamer, there was nothing else like it, and it was a great product, and it straightened and re-rounded large diameter coil pipe. And people look at it and they kind of get it, and they'd say, hey, can you bring that thing out and do a demo for me? And I'd have to ask, do you think it doesn't do what we say it'll do? We go ahead and take it out and do a demo, and we'd sell a line tamer. But that's the same with this. Of course, it fuses pipe. It fuses pipe very well. You'll see this, it's on some fused pipe tomorrow. We've got an hour at product showcase. To dedicate a machine an hour to make a joint seems kind of silly. But yes, it fuses pipe very well.
Probably got one of the best performing facers of any
Is
machine.
the facer is a real joy. Yeah. And so if people have had challenges on some of the 20-inch type pipe with facing, this thing faces like a dream, thankfully. Yes, sir.
We wanted to retain the fusion cylinders that we seen a year ago, as in, you have to chop them out by taking out two pins, very, very efficient for doing carriage rebuilds.
Right. The carriage cylinders are outside of the guide rods, so they're not incorporated into that guide rod like our conventional machines. So there are two pins. Makes serviceability of that whole system very easy, very efficient, and that's still that's what's on the production machine. Yes, sir. Good question.
You can use in this machine accessories like elbow, tees, wise.
Yeah. Yeah, so the question is, can we fuse elbows and T's fittings in this machine? It's you can operate it in a 2-jaw plus 2-jaw orientation. It has a full-length guide rod all the way from the outer fixed through the tailstock on the movable side. And you can operate in 2x2, 2 movable, 2 fixed, or you can operate in 3+1, 3 movable and 1 fixed. On that 1 fixed jaw side is where we could accommodate T's in any orientation, elbows, or anything else. Sets up very well for that.
Chris, one question. Looking at the slides, it looked like the upper inserts were a standard insert out of the 500 or obviously must be a master in there. Is that correct? Is there an upper?
I can't say that it is on every diameter, but I believe on some of the diameters, yes, you can reuse the lower inserts from legacy machines. Correct me if I'm wrong, somebody back there, but that's the intention. Okay.
And the other question is, the initial machine, the lower jaws are quite aggressive as regards to the pattern on it. Did you find much damage to pipe, handle pipe with it?
With the original machine or with the current? Yeah, those quarter inserts that are what actually close up around the pipe, that's been one of the things that I think we've seen some very good improvement in between some of the original machines and where we're at with production. There's been a lot of effort into that to make sure we don't unintentionally, gouge or damage the pipe. So it's performing very well. That's not to say you couldn't do it if you worked hard at it, but yeah, under normal situations, a prudent guy is going to be able to do a nice job with it.
In the event that the machine's not running, is there a lifting device or a way that you can pick the machine up and transport?
Yeah, the question is if your machine just won't run for some reason, how do you move it? It has 3 lifting lugs on the vehicle chassis itself, and you can use 8-foot long, appropriately rated just nylon straps to a single point lift, and you can just use whatever's capable of lifting it safely to load it onto a truck to salvage it. And it takes nothing special, just conventional nylon straps properly rated for the weight and shackles.
You did comment that that machine weighs like 10,000.
Just under 10,000 pounds.
Chris, is the unboom, is there check valves?
Check valves, I believe there is a check valve on the boom. Yeah, so if you're talking about referring to a drift or, yeah.
If you had a high force
No, it's gonna hold stable.
valves and stuff.
And then we also have the safety lockouts, you know, in the full up for serviceability.
Is this machine to build to work in ditch?
Yeah, it's great. It's a great machine for in ditch. As I mentioned, the carriage comes off the vehicle by just disconnecting the hydraulic hoses and the cables and pulling 2 pins. It really couldn't be any easier. And then it's a 4-point lift. So using those same type nylon slings like I mentioned with lifting the whole machine, you can just use any 4-point lift and it lifts wonderfully. Then you can imagine the benefits in not having to have all that additional excavation under the pipe, you know, and the wireless control. It all works very well for in ditch.
Chris, I think you ought to share that the truck driver that hot shot at the one to the utility expo was told not to unload it.
Yeah, we sent a machine to the Utility Expo in Louisville, Kentucky a couple of weeks ago, and we hot shotted it out there and told the driver specifically, do not unload this machine yourself. We want to be there to do it, you know, properly, safely, and all that stuff. Well, he arrived there before we did, and the machine, he offloaded it. He said, well, it's a big deal, eh? We're like, we kind of had heart palpitations, but he said, what's a big deal?
When it comes to the tablet, it's, obviously that tablet's got to synced with that Tritan. What happens if there's a problem with that tablet? Can you take any DL7 tablet
Yeah,
to it?
sure.
And it'll automatically, you just automatically sync it right up?
Yeah, so there's a little process for doing that. A little bit like loading an I-Series machine into a Data Logger 7 tablet, but I think it's smoother, it's more streamlined. But yeah, any Data Logger 7, you can have the same machine loaded on multiple data loggers, or you can have multiple data. You know, it doesn't care.
Well, you know this, like you guys on the field are going to tear everything up.
Sure. Yeah. Yeah.